These are the wonderful people that will be helping you. Sorry if if I had stopped sharing there. So my name is Duffy Cooley. As I said, we're going to have Christopher, Daniel, and Rich with us, and they're all going to be helping us present these labs to you. So a brief introduction into eBPF. eBPF makes the Linux kernel programmable in a secure and efficient way. It's similar to like what JavaScript is to the browser. eBPF is to the kernel. If you were to think about the Linux kernel as kind of an API, right? When I want to open a file, or I want to open a socket, or I want to interact with any number of different things, a kernel driver, a scheduler, a process, then if we, what eBPF gives us the ability to do is hook into those API calls, right? So as we see that event happen, we can actually intercept that event, make a change to that event, or even just gather a lot of metadata and context about what's actually happening as part of that call. So for example, if you were to open a file and we were actually instrumenting the file open system call, we would be able to see which file was open, whether it was successfully opened or not, and what the file location and all of that information is. And we can do this at pretty much any point in the stack. That's the real power behind eBPF, is that it's wildly powerful and is able to operate on pretty much anything within the Linux kernel, whether it's something that is kind of obvious like a file or a network namespace or a network interface, or even something that's a little more difficult to understand like XDP, wherein we can embed eBPF programs directly into the network device itself, allowing us to shortcut traffic between the network device and perhaps the application namespace or the application that network traffic is aimed for. We run eBPF programs on events, and like I said, it's a little bit like an API. If you think about it like that, it'll make sense. Where basically we have a variety of different technology or a variety of different functions within the Linux kernel, and as soon as we see those functions being called by any process within the Linux, making use of it, then we can actually intercept and take a look at it. And this is actually how we do some of the work with Cilium, right? So with Cilium, when we're doing things like writing network policy, when we're doing things like replacing kubeproxy, when we're mapping connectivity between two pods within a Kubernetes within a Kubernetes cluster, we're actually leveraging eBPF to determine whether to allow or deny traffic and how to manage that traffic back and forth between those processes. With Tetragon, we go through a different process. With Tetragon, we might instrument a different functionality, wherein we are looking for things like what processes are opening what files, and can we limit the access to particular files? Can we be alerted, say, for example, when a process that's running inside of a pod tries to escape that process, right, and jump into another pin namespace or into another container? Are there things that we can instrument in the Linux kernel that would allow us to identify when those sorts of things happen? And this is the way that we have actually developed Tetragon leveraging eBPF. So we have developed at Isovalent Cilium CNI, Cilium Service Mesh, which is a functionality that allows us to create and solve a lot of the use cases for Service Mesh without sidecars. We've developed Hubble, which is how we take all of that rich context, all of that rich understanding of what's happening at the kernel layer, whether at the network, right, whether within the network layer or within the application layer. Hubble gives us the ability to observe those things and go through that data or make use of all of that data and context that we're seeing. And then Tetragon, as I've described already, is our ability to do things like security observability and runtime enforcement. In today's labs, we're going to be exploring two different labs. One of them is Isovalent Cilium Enterprise Network Policies, and the other one is getting started with Tetragon. So if you're in the audience now, you're going to want to go to isogo.to/summer-school-2023-1. And when you navigate to this link, it's going to give you a choice between two different labs to join. And that choice is yours to pick. Don't start the lab yet. We're going to break into our breakout rooms, and that's when we're going to really get started on the labs. But for now, go ahead and follow this link, isogo.to/summer-school-2023-1. And when you land there, you're going to see two labs available to you, Isovalent Cilium Enterprise Network Policies and getting started with Tetragon. Today, I'm going to be working with you on the Getting Started to Tetragon, and Christopher Luciano is going to be working with you on Isovalent Cilium Enterprise Network Policies. So I'm going to stay here for another minute here so you can go to this link. You can also capture this URL with this QR code here at the top. These labs are going to be available to you for some time, so don't worry too much about rushing through them. But if you do make it all the way through one lab and you want to jump over to another lab, that is available to you. Both of the labs are available to you for this session. Both labs come with a certificate, right? So once you've completed them, you're going to get a certificate, which is why when you're looking at the page that you clicked on here, it's asking you for your name and your information so we can get you that certificate. Go ahead and provide that information and we will get you started with the labs here pretty soon. See if I have a question in the chat here. Oh, sorry, let me go back. Good point. Thank you, Thomas. So Thomas has actually put the link in the URL in the chat, which is probably something I should have done as well. So that's a great idea. Thank you very much. All right. Moving forward here. So thank you for joining session one. We really appreciate having your time. It's a great opportunity to learn a bit about what we're doing here at Isovalent, and I'm really looking forward to working through the labs with you. Now, in your UI up at the top here, the way you would like interact with chat or turning on your camera or your mic or anything, you'll see a breakout room section. And in those breakout rooms, there are going to be 2 breakout rooms named appropriately for the 2 different labs. I have a question in the chat. It says, is the Tetragon lab the same lab that is available on the Isovalent lab page? It should be, yes. Once you have selected which one you want to join, you can join whichever lab is available, whichever lab you picked, whether it's networking security or security observability with eBPF and Cilium Tetragon lab. So you can go ahead and move in there, or you can ask any questions that you have in the chat. I'll be here for just another minute or two as we get ready to move, as I'm looking forward to seeing you move into those rooms. So go ahead and move into the rooms, and if you have any questions, we can answer them in the rooms, or you can ask them in the chat here. All right, awesome. I'm seeing people move into the rooms. Looking good. All right, I'm going to stop sharing this presentation, and I'm going to jump into the room myself. So we will come back to this page here in just a little while.
Let me just click record here. Okay, there we go. So we're going to take the environment variable listed here. We're going to utilize this later for when we're using our observability tool to take a look into the network flows. So that's going to be up on 3214. And now we push forward towards the networking stage. We want to be sure that our nodes are ready. And we are ready. So if you haven't gotten to this point, please ping in the chat. If you're having problems recording the session, let me know. Otherwise, I'm going to go ahead and select next. All right, as noted, we're going to start up a few different namespaces just so we can see how network policies work across namespaces, how they work within the same namespace. So you want to go ahead and create 3 namespaces and then insert the correct service inside of those relevant namespaces. The copy and paste command, I would suggest you making use of that as often, because it could be quite a lot to type out by hand. So when Cilium first starts up, it'll start to post if it's ready. If it's not, if you did this really quickly, you might notice that Cilium will say like an error or warning. That's perfectly acceptable per se. It should start very soon afterwards. So I would expect that if you went ahead really quickly. So once we click Cilium status wait, we get an overview of all of the various components inside. We've got the Cilium agent itself. This is your CNI, as well as a few additional containers. Some of those are used for observability, such as Hubble Relay, and then Hubble UI is just visualizing this Hubble Relay. The Hubble component itself is actually embedded inside of the Cilium agent. So what Hubble Relay does is it goes and takes a look at all of the various Cilium agents and homogenizes all those flows together, so you can get a full view across your cluster. The Cilium operator is not an operator in the traditional sense in Kubernetes. This is really just something that we use to almost run distributed jobs or whatever we need to do. We don't need to run everything on each and every node, like collecting up identities in general that the whole cluster kind of shares. So we do that through this component called the Cilium operator. We can also take a look, as mentioned, to make sure that Hubble is able to reach all of the various endpoints. So that's what we're going to use this Hubble status for. If this did not work for you, it's likely because you didn't have the environment variable exported. However, that should have cleared out here. And then if we want to list each individual nodes, that's what this command is showing here as well. Next, let's make sure that our application deployed correctly. So we do have tenant A, a front end, and a back end service in each and every single namespace. So we should be good to go. Right. Not seeing any comments or anything, so we'll go ahead, move along. So in order for us to actually visualize things, we need to make sure that our applications are talking with each other. Sometimes you'll get started with Cilium and you'll notice that you don't see any flows in your Hubble UI, and it's likely because your applications aren't talking to each other at the moment. So that's what this first step is going to do here. It's going to make sure that we're connecting to all of our backends in each and every single one of these tenants. And our expected response is going to be a 200. We can also try to talk to the outside world. This 301 is expected because this API.twitter.com has actually kind of gotten changed. But the thing that we don't want to see here is kind of a network policy blocking it. Now we could take a look and use that Hubble application that I had mentioned before to visualize this. So we see looking at our tenant A front end application to all of the instances where we try to reach out to some backend instance. We also see cases where we try to reach out to a specific outside world as dictated by this world identity. So each and every single flow that passes through is associated with a Cilium identity, and identities to Cilium are dependent on whatever pod labels that you apply to an individual service. So this front end service is going to have a different identity than the back end service, as noted here. And the purpose of this is so that whenever we're applying policy, we can always do that against the identity. We don't need to rely on the IP addresses. So if these pods get spun up elsewhere, we're still going to be able to apply the same policy. There's a lot of optimizations in terms of just policy throughput and everything that we want to be sure to take advantage of. When we're looking through here, as noted, you'll see the timestamp or timestamp. This should be just during the period. You can also follow the output much the same way that you can follow any other normal logs. And here we're talking about where this is actually getting noted. So this could be to the actual endpoint. It could be to the stack, meaning that it's kind of reached into the host kernel itself, or it could be on the overlay, which would be within inside kind of the Cilium. And the important thing here is to note whether things were forwarded or dropped. We haven't created any network policies yet, so I don't expect any drops to anything. Then important to note that the Hubble observe command is actually very configurable. You can put in here whether you want this to be from like all pods, whether you want to look at a given namespace, and also a given protocol. There's plenty of other flags too, which we'll get to later. So we're moving on. Just be sure to throw your questions in the chat if necessary. And we have Daniel Chan here to make sure that everyone is progressing along. Nobody has any questions. Is everybody on the quiz section here?
Almost. There's a few people that are, a couple people that are in the first stage, but most people are in the quiz.
Okay, great. So this is a good opportunity for us to kind of test our knowledge of network policies in general. Certainly what I'm going to be doing in front of you right now. So the question here, when no network policies are in place in the namespace, what's happening? All right, this one's fairly straightforward. So I would expect, yes, all traffic is allowed. All traffic should be allowed to other namespaces, pods on other namespaces as well. We haven't done anything. External addresses, we saw that we were able to contact twitter.com, so we didn't get any denies there. So I think it's appropriate to select all of these. All right, that would have been embarrassing if I got it wrong right out, but press forward. So now let's start to add policies, and that will change the answer to a lot of our questions here. As you'll note here, we're immediately greeted with the Hubble UI. So Hubble UI talks to that Hubble relay. Whenever you're using that CLI, it's going to connect to the relay. And that's just because the relay is taking a look at all of the various flows and aggregating them for the cluster as a whole. And then since that's already done at the Hubble relay level, the Hubble UI can take advantage of that. So with inside of here, you'll see at the top how many Hubble nodes you have. So this should match the exact output that we got from doing Hubble status before. We've got our policies tabs, we've got process tabs. Processes is we'll get into a lot more in the other session. However, let's go ahead and take a look maybe at the default namespace here. This is the spinning bar that I had mentioned. If you don't have anything in here, you're probably going to see this spin. What we should see is traffic in one of the ones where we actually did do this. George, yes. So let me paste that link again here. So you go to that link right there, and then we are on the enterprise network policies. Right. So now what we're going to do, we're going to take a look at we're going to follow along what the instruct's telling us to do and take a look at the policies tab here. Immediately, we don't really see anything, and that's because, as mentioned, we haven't created any network policies. But what we do see here is some examples of potential policies. So I'm in intended A, which is something that I know that we have created traffic in. And because of that, the enterprise edition here is actually going to show you all of those commands. You're going to be able to see kind of an example of network policies that you could potentially craft here. And that's because regardless of whether network policies are being enforced, we can suggest them to you based on historical traffic. So now let's go ahead and craft a network policy. So we'll do that by clicking on this little page icon here. I'm gonna just make this screen a little bit bigger. So when we look at the Hubble UI here, we're greeted with a pretty straightforward way of crafting, having a WYSIWYG editor for these policies. So the first thing we're going to do is craft a policy as mentioned here. We want this to be in a particular word called, so you can go ahead and just edit. Oops. Yep, no problem, George. And feel free to kind of move forward at your own pace as well. So the first thing we're going to do, we're just going to follow along for the instructions here. So we'll call this our default policy. I want this to apply to tenant A. It's already filled in for us because we're already inside of tenant A. And we'll leave this empty just so this matches all of our various endpoints that we'll be selecting. Let's go ahead and save that. Right, as mentioned here as well, we should see this reflected over here. This is whatever we placed in our WYSIWYG editor here. This is coming into this tenant, and this is going what this given namespace should be able to contact elsewhere. So we're selecting all endpoints, so that affects all endpoints within the namespace. So let's go ahead and look at like a default deny rule here. So default deny is actually just several more curly braces in this case. So I'm gonna scroll in a bit here, and we can see that right here. We can select what an ingress default deny would look like, as well as the egress deny. So you should see clear green and red bars whenever we're doing these. And I think I skipped forward a bit. So once you actually have crafted that policy, you're going to want to take said policy. What we want to do now, we want to click on the ingress default allow and egress default allow. Place that on our policy here. That will be our default. Make sure I did that. Yep. It's our default policy. Now we have the default. Now I'm going to start allowing specific traffic in the policy. So what we want to do here is allow ingress workloads in the same namespace, egress workloads in the same space, and egress specifically to core DNS. We don't want that to be blocked immediately. So allow to any pod, repeat this for the namespace. Allowing ingress from the namespace. I'm allowing egress to any pod in the namespace, and I'm allowing to kube DNS. So let's make sure that my policy that I kind of crafted here looks like that. It does. Now I want to save this. So we collect the editor tab. We've got this default policy here. I think I forgot to save it. Right. Another quiz coming up. Any questions along the way? I'm not seeing anything in the chat. Right, base policy quiz. So I want to select all answers that might apply. I thought I had a question. Okay. So Salient supports standard network policies. This is true. Hubble UI allows you to create Salient network policies. Adding an empty ingress rule blocks incoming traffic, adding an empty egress rule blocks incoming traffic. So this would only be for the ingress side. An empty egress rule shouldn't block incoming traffic. Same like without to filter DNS requests to group DNS. This is also true. I'll be honest, I want to select this as well because it would allow you to create network policies, but very specifically, it's not going to enforce them without your approval. So obviously, it's trying to say that only a couple of these should be appropriate. So I'll pop up the Hubble UI one. All right. So as noted, the Hubble UI will allow you to create the policies, but just kind of view them. So it's really there to be the source of truth for a case where you want to kind of mess around inside the cluster. Maybe you want to visualize someone else's network policies elsewhere and use that WYSIWYG editor. But very specifically, regardless of whether you're creating these policies in the editor, that's not going to apply. I had to take that out to an editor and actually save that so that it would apply later on. And this is a very intentional thing that we did within of Hubble UI, such that you can follow your same CI/CD sort of deployments as you will. We're not going to get in the way of that. So that's an explicit decision not to do that. So now that we have that policy, I want to go ahead and apply that. And now let's see what happens if I try that same. I expect that this is going to succeed because I'm allowing traffic inside of the namespace. I'm not allowing traffic outside of said namespace. It does appear that I got back at 200, and let's use Hubble to see what Hubble thinks about that. Hubble thinks the same thing. So with inside the namespace, I'm perfectly fine. I don't see anything here that suggests that I denied. So that is this a forwarded command here. Also, yeah, when you are in the previous kind of piece there, make sure you click that little save button at the top. If you know, I made the same mistake. So it looks like a little floppy disk icon. If you click on that, you're good to go. So as far as testing out denied policies, so our policy specifically should just allow us to access things inside of our namespace. And I think we can actually visualize that here. So if I cat this out, I see inside of this tenant A namespace, all endpoints should be able to talk to all other endpoints. And since this is listed at the namespace level, I'm saying all endpoints within said namespace should be able to listen to each other. And then if I want to visualize things from a higher level, as far as DNS, what I'm doing here is I'm saying that things within inside this namespace shouldn't be able to talk to just everything outside. Very specifically, I want it to be able to contact kube DNS. I do wildcard this such that even though I'm not specifically allowing you access to everything DNS-wise, I want to be able to visualize it. And that is using the internal statistics that we have in order to take a look at, whoops. Okay, very quickly, I want to add that in. I put in a max time in there just because I want to make sure that that fails. So let's take a look at drop traffic here. So if you didn't click the check button and you managed to get something in there real quick, you should see that you had denied traffic. So what I'm seeing here is my tenant A service tried to reach out beyond the scope of its own namespace across to tenant B to contact the backend service. Perfectly allowed when we first were trying this out. Obviously, now that we have a network policy in place, I'm not allowed to egress out from there. Now, the other thing that we note here is, as mentioned, there's plenty of flags that the Hubble process allows you to do. So one of them is going to be this Hubble observe sort of command. So you could just put Hubble observe in here and say you want to see everything. All right. But very specifically, we're actually interested in some of the commands that we just ran here. So we're going to scope this to just this individual namespace. And verdict is going to allow us to take a look at maybe just some things on the borders, some things that are abnormal. I want to see all of my dropped traffic in this case. So what this will do is, as probably assumed, is only going to show me the dropped verdicts. Now we want to take a look at Hubble UI just to see what is happening there. So I'm going to go back into here, take a look at tenant A. Should see some traffic here. I do see some attempts to the outside world here to my backend service. I can also select, as I did there, an individual service, just if I want to be concerned with what did front end try to do versus what things they're trying to contact backend service. If you note here at the top, when, as mentioned before, we select this always based on identity. So this backend service itself has its own set of labels here. And these labels are put through a hashing algorithm and it spits out this identity. And whenever we try to enforce or take a look at a policy, we're always doing this based on the identity. Even the outside world itself gets a form of identity. Right, let's move on here. Got a Hubble observability quiz. All right, when using Hubble, I'll select all the answers that apply. So the Hubble CLI allows us to observe all traffic. Hubble CLI and UI always display external DNS names. Hubble service map displays connection drops. Hubble CLI output can be filtered by a pod. Question from Kunjo. Question, how are identities assigned? Identities are assigned based on the pod labels, as I was just showing. So if you think about a deployment, the deployment is used for, what a set of pods or a set of, okay, so what component is responsible for this? So each individual Cilium identity keeps, or each individual agent keeps an identity mapping itself. There are ways to get around this with some more advanced tooling, such that identity could just be a DNS entry. But each individual Cilium agent has a map that it uses. A map in our concept is an eBPF map. And this is just a data structure that is within inside of the Linux kernel itself. So whenever you're making decisions, like at the transmission control level in the Linux kernel, whenever you try to do a process connect out to something else, this is an opportunity to run a bit of eBPF code, which Cilium is based around. So as soon as you make that connect, we run our little snippet of code to make sure that you're able to actually make this call. And we do that all based on the identity. If you're using certain encapsulation modes of Cilium, that identity itself, once calculated, is actually passed inside of the VNI field of the encapsulated packet itself. So you would be able to visualize that and see that on alternate nodes. So when the packet reaches over to the expected destination side, it as well is going to be able to see the VNI and translate that back to that list of labels that are signed. So this is always like the label set and the identity. And then there's different maps for different things, different maps to store service and backend association, maps for policy, maps for all of the IPs that I handed out, things like that. So last one here, I would definitely believe is true. Hubble service map does display connection drops as well. As far as always, of course, is one of those clarifiers. I would say it's not always going to show the external DNS names. It would only show that if we told it to do such. And does Hubble CLA observe all Kubernetes traffic? We should be able to see everything that is within the confines of Kubernetes. There's certain things that we might not see. Let's see what it says with these first two, but I'm kind of hung up on one here. It's only expecting one answer. Nope, it is two. Okay. I was thrown off because it says like one of one, of two, and I read it wrong. So as noted before, it is going to show you kind of everything, but the second kind of question is almost like a clarifier for that. So if you're not showing DNS policies, it depends on how granular it actually shows. As mentioned before, in the opposite section, they're actually taking a look at this from a deeper level, from the system call perspective with Tetragon. At the moment, we're just concerned really with layer 3, 4, and 7 out on the wire here. So next thing we're going to do is take a look at some of these other policies. Since we crafted a policy in here, when I click on policies in my given tenant and namespace, I should be able to now see a particular policy that I created before, which I do here. I see this default policy that I crafted before. This is only going to show up if I actually went to the editor, saved that, and then it got rolled out everywhere. So that's the reason why I see it here. So just a note here as well, you can also use the editor to take a look at just dropped things as well. So let's create a new policy here. If you get alert about your unsafe policy, all right. So as mentioned, we want to craft a new policy, create a new empty policy. I'm going to get over here. I'm going to call this, whoop, too fast. Call this extra. Oh yeah, just noting our flows out to the backend service of B over here. So this is what we're going to be creating a policy for. Too fast. So if you didn't post it out to a YAML file elsewhere, will it keep it kind of like in the cache, as in, I assume the web UI cache? I believe the answer to that is actually up here. Next week policy. I swear I just saw something that said you might get a warning saying that you're kind of overriding some sort of unsaved policy. I don't believe that it will save that. So this is all like a live sort of thing. So whenever you create the new empty policy, I don't believe it's going to save somewhere else if you didn't put it in this editor tab. Perhaps in your paste buffer, like from on your operating system.
Yeah, and just as a note, it's okay here because the first policy that we created, we actually saved on disk and we applied. So it will appear in the Hubble UI as parsed from Kubernetes. So we don't need to edit it anymore.
Excellent. Thank you, Raphael. So I'm going to save this just so it's my here. And now I'm going to follow along here. So what this is saying is we actually want to use some of these ideas. So you can go ahead and click add this rule or policy. Now automatically it's filling in the endpoints saying that I'm allowed to talk to X and Y. The other thing that it wanted to do is allow me to reach out to twitter.com. But I just noted that I did not actually do anything out to twitter.com here. So let me see. So in my paste buffer, I actually had something like this. So let me try that out. So if you did miss that, like I forgot to do before, you can go back to your terminal page and then just take the same command that we were doing to try to reach out to the backend service and do that to api.twitter.com. And then when you go back into your Hubble UI here, you should see another case where there was a dropped flow here. So now I can go ahead back to that, as mentioned here, add that rule to my policy. So in here, what I should be able to see now is that I am able to contact the backend service in B. And I'm also able to now reach out to the outside world on api.twitter.com. Here it's talking about the extra policies here. I can also visualize all policies. I want to do that in order to see default plus extra. Can I see all of those at once? So I see I'm able to contact group system, which is the policy that I had before. I'm able to do the backend service. Now when I take said policy and copy that over to my editor tab, I'll select the extra policy I've noted here. Make sure to click that save button right here. Now I'm going to go to my terminal tab. I'm going to copy this down. I'll have to type it all out. And I'm going to add in that tenant A extra policy. So let's see if we are able to contact now. So first thing I'm going to do, I'm going to try to contact my own tenant A, which I'm allowed to do. Next thing I want to do, I want to try to contact the outside world. Am I allowed to do that? Yes, I am. Despite it being an API that got moved, I'm still able to contact it. I'm not seeing that it got blocked as I was before. Now let's see if I'm able to access that tenant B namespace. I did create a policy for it, so hopefully this works. It does. But very importantly here, what I shouldn't be able to do is contact things that I don't have explicit policies for. So let's try to reach Google. That'll time out after 5 attempts there. Still not able to do that. Also not able to contact tenant C, only A and B from my tenant A namespace. So I see that failing as well. I should see that in Hubble UI here. I am. And if I want to take a look at all of the traffic from tenant A once again, I can do that here as well. So I'm still seeing some denies here. I'm seeing allows to things that were denied before, but still not able to contact tenant C's namespace. Click the check button. It wants to be sure that you saved all of your stuff. So my invocation from front-end service to back-end service tenant A still hangs in this dropping. Unfortunately, I think I just went past that. So my guess is that we did not apply our tenant A namespace pod. So what you could do, you could go to the editor tab, and then you would have had saved in there the tenant A default policy. So you want to flip over to your terminal and apply that policy as well. Raphael said he's taking a look into your session here just for some further clarification, but my guess is it's probably that. All right. Here's another quiz that I successfully get wrong in front of all of you again. So let's see here. Rules can be added to an existing network policy. I remember explicitly that that is the case. Rules can be added by creating a new network policy, of course. Hubble Network Policy Editor allows to edit existing Kubernetes network policies. If you did apply and edit and save those before, I believe that that should work. So yes. Modifying automatically applies them to the cluster. This is the one very specifically that I was saying before does not work. So we had a question similar like this before, asking, we could create them. Does it actually apply them immediately? No, I had to take them and put in my editor and actually click save. This is something that I believe one of our colleagues was just mentioning we're going to need to do. Hubble cannot let you view all policies applying to a namespace at the same time. Well, there was that visualize all button, so I believe that that should work as well. All right, let's see how. Incorrect, too many answers provided. So which ones do we want to drop here? Rules can be added, creating a new network policy allows you to add existing Kubernetes network policies and cannot let you view all policies applying to namespace at the same time. Let's jump off this one. It's saying there's only 2 correct answers. Those could be added by creating a new network policy. Well, not enough answers. All right, cannot let you view all policies applying to namespace at the same time. Perhaps, Raphael, maybe what
I'll have
is
to
this
review this
question
one.
actually? What's that?
I'll have to review this question.
Yeah. So my assumption was it does allow you to do that because you can select the visualize all.
Yes. It should.
Okay.
Maybe there was a problem somewhere in this one.
Look at that. Finding bugs. All right, but now the last exam is okay. So we get a badge after this. So I'm pretty excited. This is part of a practical exam here. So let's just make sure that we follow things as it says. Okay.
Sorry, to clarify, it was a double negation, right? Because the
wording
question was Hubble cannot let you view. So that's incorrect because it can.
I understand.
Sorry, tricky.
You got to throw in some wording like that. Yeah. All right. So what it wants us to do, it wants us to create a policy called default exam in the namespace. All right. So let me go into my policy editor, make this a little easier. It says it wants us to be in the tenant B namespace. So I can go into here. I can create a new policy. And what this wants me to do, it wants me to allow traffic to google.com on port 443 from all pods in namespace tenants B. So I am in tenant B namespace already. Whoop. I'm going to come into here and I'm going to call this the default exam policy. This should allow me to now be able to allow Kubernetes DNS traffic. So that is flipped on. I also want to allow traffic outside the cluster as mentioned to google.com. So I can click the FQDN one, type in google.com 443. I'm going to add that to my rule. Now I'm going to allow traffic to the backend service in a separate namespace. So I could do that here. So over here. And I'm going to do this to backend service. Click too quick. Okay, it's actually good that I cancel it anyway, because this is very specifically wanting me to do this to tenant C. So now I can put tenant C in my namespace selector. And I want to be able to access tenant B or tenant C's backend service. I'll put that in here as well. So backend service port 80. This looks correct to me. So I'm going to edit that rule. So let me take a look here. I'm able to access agency. It's called default exam. I'll be able to contact Google. Let's see what this looks like.
Yeah,
in
another
the
way of
bigger
doing it,
section
like
here.
it says in the notes, is to actually do a request, and then get it from the Hubble logs to edit.
Oh yeah, that's true.
So you create the first,
that's reference.
the first couple of rules that you apply, and then you make a request to tenancy. It will be denied if you already apply the first two rules, and then you can add it.
So I could do
Love that
something
trick.
like make an exec here from my front end
Exactly.
service
Yeah,
to back end service tenant
exactly. Tenancy.
C.
And this works because you haven't applied the first rules. So you might not see it in Hubble UI actually.
Oh, I already did it.
But that's all right.
All right. Well, let's see if it thinks that I did it. All right, it's not found yet. Yeah, so
You
I didn't
applied?
actually create it. No, I put it over here, but I didn't create it. So let me just be
Yeah,
sure.
so you could apply
that's-
this, because if you apply this, you already have egress rules.
Yeah, I was looking at the wrong thing here.
Okay, yeah, sorry.
So this is actually what I wanted to do. This is the actual exam one that I did here. So this looks correct to me. I want to save that. Let's see if it actually worked. Default exam.yaml. All right, it's actually crafted. So now I should be able to try this out, and let's try from tenant B to access google.com. Terminated. Service to Google. All policies. Yeah. I must have pressed too many things at the same time. All right, so since I created it already, should be able to do is just visualize where it went. So now I should see 3 leads, I believe. Yep, here's my default exam. I am allowed to contact that backend service. I'm allowed to contact Google. And I should be able to contact kubedns as well. So let me add that to the rule. That was my missing piece here. All right. Save that. Let's get that badge. Nope, still doesn't allow. So I've got default exam here again. It's saying that I'm not allowed to contact my DNS app. So what would be the problem there?
Let me check what could be wrong.
Looks like Daniel spotted it in the chat. He says you're missing 2 endpoints brackets.
That should be necessary actually.
Oh,
Can
sorry,
I
that
see
was,
the-
that was just with
Can I see?
someone else.
Let's see. Egress Google comment, that's correct. And 2 endpoints. Namespace cube system, cube DNS, to port 53 UDP rules. So wait.
Oh, does this mean the 2 endpoints within
Rules
inside of my
DNS
own?
match pattern, that's correct.
Yeah.
And 2 endpoint match labels. Okay, the tenancy looks fine as well. And you apply this? And it's called default exam. Is the rule called default exam?
Yep.
Can you check? At the top. And it's in tenant B. Yeah, that looks correct.
Is it
Looks
because
correct
I'm
to me.
not?
It looks correct to me.
Maybe this is it. I think. Problem is that I wasn't allowing potentially 2 endpoints with inside of my own namespace,
The
perhaps.
2 endpoints shouldn't be necessary.
Let's see.
Right. So that's the tenancy. Can you see it again?
Yep.
It would be easier if you had done like the request. But let's see the tenancy rule, which is at the bottom. So tenancy, and you also need K8s app backend service in there, or at least app backend service, because it needs to filter to backend service specifically. Here you're allowing
Right.
everything to tenancy, and we're checking that it's actually only to backend service.
Yeah. It's weird that I put this in actual thing. But I must have copy and pasted like several different
Yeah, or you can fix in the
things at
YAML
once.
already. So this one, yeah, the pod selector should be app backend service. App equals
Yeah,
backend
I
service.
must not have clicked save.
App equals. You need app equals, yeah.
Get it here.
Like in dash service.
I did a dot.
Yeah, that's not valid.
So let's do this again. I'm allowed to contact things inside my namespace. I'm allowed to contact specifically backend service and tenancy. I'm allowed to contact Coop DNS, and I'm allowed to contact Google.com. I save that. I apply. Get badge.
Yay.
Excellent.
So the other way
be
that
sure to
might be
follow the
easier,
steps.
the other way that might be easier exactly is create